Hi everyone. This is the ML Study Circle sponsored event by the ULTF volunteers, and this is for C-DAC PG Diploma in Artificial Intelligence. So this is a C-DAC PG-DAI Study Circle, and Jaimit Vasawa is our leader, and we expect to see many more people join this as we move from what you call the study circle. This session is just the beginning, and I will hand over to Jamit Vasawa to ensure that he is able to provide you the insight, and then as more and more people will join over next 1.5 months or so, this is a 3-day week, evening 8 to 9:30 p.m. Indian Standard Time, uh, and we'll be covering the details. And I will let uh, Jaimit Basawa, the leader for the PG-DAI Study Circle, take over. Thank you. Jaimit, go ahead.
Thank you, Professor, for the introduction. So, hello everyone. My name is Jamit Vasawa, and after the AIML study circle, we have started the study circle for the C-DAC PG, which is postgraduate diploma in artificial intelligence. So the contents of C-DAC PG-DAI is this. So section 1, there are 3 sections, section A, B, and C. So the contents of section A for the entrance exam that they expect to from the candidate to have is are these. So English, quantitative aptitude, reasoning, computer fundamentals, and concepts of programming. The lecture that is being conducted right now.
Little louder, okay? We need to have proper record.
Okay. So the section A consists of these contents, out of which in the today's session will be about computer fundamentals and concepts of programming. The section B, it consists of these contents, C programming, data structures, and whatnot. So the requirement for a PG diploma in AI has only 2, which is section A and section B. But there is also a section C for some other courses. As we are focusing on only PGD AI, so we are be focusing on section A and B only, which are the requirement. So these are the details as we have mentioned in the meetup group, as well as the here also. So we'll be following these this timetable for lecture 1, which is this one is computer fundamentals and concepts of programming. Then 2 through 6 is C programming. Then data structures, operating system, and a total having 20 lectures. If there are any changes, we will be letting people know about it, depending on the subjects.
Jamit, I would like to interject here. Yeah, sure. See, currently the PG diploma in AI exam study or the course curriculum, new course is still not announced by C-DAC.
Yes.
And so we are working with them to find out if there are any changes that might be required for future, and that's an activity which I'm working with to be able to get a better reflection on what should happen, because the exams generally take every year it is different. So right now 24 is already announced, and the selection is over. But for 25, we expect that the section A may not change a lot because it is more of analytics, and fundamentals of computers don't change a lot. But the This is more to do with quantitative reasoning, aptitude, and all that. The section B, however, is something more uh, detailed and depends on the current structure. Current structure looks like is based on C++ and Java and quite a bit of older, uh, what you call, older reality. The current reality is a lot of people use Python, and that's for the data structures and including object oriented programming and all. So we do expect that there will be some revision needed and that we are proposing from our side. And currently we will just follow the old one, but also prepare you for the new one. I will be, along with our EOTF colleagues, we will be recommending to Jamit as to what he should be taking. And so we will address that in a way while we are running the course. So it's a interactive, and if you have any suggestions, you can also propose. We'll try to see if the C-DAC course need to be revised. With that, I'll again stop talking. Let Jamie go ahead with the proposals, what we have.
Okay, thank you. The details that Professor was talking about has also been posted on the CDEX website in the syllabus, uh, in the course content, where you can see the required skills and stuff. So this is the timetable that we will be following. So now I'll be starting the computer fundamentals and concepts of programming. So, so this is a short summary of the whole reference book that has been recommended by C-DAC, and it talks about the origins of computer, the need of computer, and till the present date, and how a computer used to dif- handle the things and stuff. So, so evaluation of computers. It first started with the help for the reason of being so there are different equipments being used, like abacus or an EPS bone for a calculating device. But the people who are proficient on those devices were able to calculate it very fast. But the need for it has to arise when more people can use it and more use of it can take care of other things. So the first gen computers were created. So also I would like to mention that Charles Babbage, who is considered as a father of modern digital computers, he created the first difference engine, and based on that, other evolution of a computer are done. So computers are also divided in generations. So the first gen computers were mechanical and had vacuum tubes as switch gates. So, so as you can see, the time frame in which it appeared uh, s- uh, and the first computers that were created. Then there were second generations, which replaced vacuum tubes with transistors, and with also addressed the shortcomings of vacuum tubes they dissipated heat and stuff. So transistors addressed those issues, and made the computer very easy to work with. Then the third generation had ICs, where which consisted of different components, being electronic components resting on the chip. And the IC started with SSI, which is a small scale integration, where 10 to 20 components were there on the chip. Then medium scale integration with hundreds of components on the chip. Then in the fourth generation of computer, it had large scale integration and very large scale integrations, where very large scale integrations consist of millions of electronic components. Then in the fifth gen, which is the present one, we can say is had ultra large scale integration with 10 millions of electronic components. with them. The future gen can contain quantum with HPC parallel plus time sharing. So with that, there are some characteristics of computer. So computers are automatic. They do not need any supervision once the task is assigned to them. Then they are quick in the way they operate. They are accurate in the job they are assigned to do. They are diligent, means they do not get tired or exhausted. Versatility, they can do various different jobs for what they are programmed for. Then power of remembering, they they can remember the things for they have the remembrance mechanism, which are hard drives first, and then before that floppy disks and stuff, where the data that they are working on can be stored. Then they don't have any IQ of themselves. They only do the task that they are programmed to do. Then similar to no IQ, no, they don't have any feelings like humans do. So further, they have the data processors and input-output devices like keyboard, mouse, scanner, etc. Memory for storing the data. Then CPU. CPU is the central processing unit, which consists of ALU and control unit. Then the basic operations of computer. So inputting, storing, processing, outputting, and controlling. So storage types are primary and secondary storage. So primary storage is basically the storage that the computer stores while the program is being run. And as soon as the program is completed or the computer has been switched off, and that storage is lost. The secondary storage is more of a permanent kind of storage, like hard drives and stuff. Hard drive of the computer, where they are more permanently stored, can be erase, rewrite, uh, and edit them. So as I mentioned before, the CPU is a central processing unit, which consists of arithmetic logic unit and control unit. So control unit acts as a central nervous system for the whole computer, and arithmetic logic unit. So is control unit basically handles the way tasks will be handled and given to the arithmetic logic unit, and the arithmetic logic unit will be actually processing the data for the given task. So you can see the one human architecture uh, based on which more of the computers are designed. So we have input to the computer, the processing unit of CU and ALU, the exchange between memory and CPU for the needed data, and then giving us the output, while also taking the input from the peripherals and other computers. So, so whenever we are talking about it, the computer understands in number systems. So the number system started with a non-positional number system and positional number system. Non-positional number systems are just uh, keeping the count with the help of lines. So let's say we draw 4 lines for 4 quantities, but in such representations, it's hard to calculate and keep count on, and it had a lot of error. It can it has a lot of chance to make errors. The positional number systems uh, are the one that we are currently using. So we have a decimal number system, binary number system. A decimal having 0 to 9 with base 10, binary having 0 and 1 with base 2, octal number system with 0 to 7 with base 8, and hexadecimal number system for 0 to 9 and A to F for uh, for the digits after 9. and having the base 16. So the number system also consists of the conversion of one number system from one number system to another number system. And as we all know that the computer always work with binary number systems. So so you can see the some of the examples of conversions from decimal to binary, hexadecimal to binary, and then octal, and etc. So, so the computer codes were now introduced as binary was used. So the binary was but so as binary is being used. So the need of using the letters or alphabets to be represented within the binary with the help of binary number system has been introduced. So this is the representation of BCD code where you can see the character and the representations and octal equivalent. Also, just the way BCD code exists, we all know that there is an ASCII value for all the A starting with 65. So ASCII is an American Standard Code for Information Interchange, which represents the characters, and also it is capable of handling many other characters apart from the listed one. So now the computer arithmetic, as we are dealing with binary. So why binary? Because it's easy to work with, as a computer has to deal with only two numbers. Then so as the computer is dealing with only two numbers, and the need for arithmetic of it and has will be there. So you can see the rules for addition in binary and subtraction, but but in computer systems the addition and the subtraction is also done with the help of an additive method, which is also called as complementary subtraction. Similar is the case for a multiplication, and additive method for multiplication, and division, additive method of division, etc. So now we have, so as we have uh, started to do with advanced use of the binary number system for representing numbers and stuff. So there is a need for Boolean algebra and logical circuits, uh, which are fundamental concepts of algebra. So logical addition or operator, which is denoted by plus, and logical multiplication or AND operator, which is denoted by a dot, and the computation or a not operator, which is denoted by a dash or a minus sign. So operator precedence is also a rule that is followed for different expressions that are represented. So the rule to it is the expression is scanned from left to right. The expression enclosed within the parentheses are evaluated first. All complement or not operations are performed next, and all the dot operations are performed after that. And finally, in the end, the or operations are performed. So there are postulates of Boolean algebra, principle of duality. So principle of duality is basically the the rules that are true for OR operator will also be true for AND operator. So theorems of algebra proof by the method of perfect induction, etc. Then we have Boolean functions, sum of products and products of sum, logic gates and or not NAND, which is negative or negative or and explosive or. So design of combinational circuits. So so there are these logical gates are not used in single terms, but rather they are combinationally used in order to get the desired output and designed to get the desired output. So, so you can see the simple implementation of these gates. You can see the truth table with input one and input two, and the respective output of the given gates. You can also see in the various logic gates and the symbols. Moving further, we have a processor and a memory. So while whenever the computers were being operated, there were certain registers to the instructions that were being followed. So the processors had to follow had registers and the processing speed to process the instructions. So and that was the what was the speed of the processor was based on. Further, it was also divided with the help of CISC and RISC. So CISC is basically complex instruction set computers and reduced instruction set computers. So complex CISC basically had a lot of instructions that were needed, and but later on the manufacturers figured out that a lot of instructions that were given in the CISC were not used, so they reduced the number of instruction and reduced instruction set computer for the ones that were only useful or more useful. Then and there was EPIC, which is explicitly parallel instruction computing. Now moving on to main memory. So you can see the different types of memories that were available, where programmable random read-only memory, erasable programmable read-only memory, ultraviolet erasable programmable read-only memory are the ones that were later advanced, where it started with a simple ROM, which is a read-only memory, where the computer was only once the instructions were written, or once it was written, it cannot be erased and stuff. So that so the so that is the reason it is said as a read-only memory. So it was used for more of the system software side, where the manufacturers uh, saved the boot files of the computer, where there was no need to erase them or modify them. So next is interconnection of CPU with input-output devices and interconnection architecture, which is universe, dual bus, and direct memory access and stuff. Next is secondary storage devices. So for storing the data in more permanent sense, so sequential and direct access devices. Then basic principles of operation of a magnetic magnetic disk, floppy, hard disk, optical disk, magneto-optical disk, USB dongle, which are more used now. Same flash memory and etc. So the from magnetic tape to magneto-optical disk, and these were more prominent in the past as compared to now. The magnetic tape is a sequential tape, which means that in order to get the entry of the first of the 10th entry, one has to go through the ninth entry. So those were the kind of things which were there when the storage devices were evolving. Now the input-output devices. So keyboard input devices have keyboards, point and draw devices, data scanning devices, digitizer, electronic cards based devices, voice recognition devices, vision based devices, offline and data entry devices. Then output devices, these are monitors, printers, plotters, computer output microfilm, screen image product projector, voice response systems. The So the computer software can be uh, understood with the help of this Venn diagram, that it's hardware, then the system software or the OS, and on top of that, the application software. So as we have talked about the softwares that are being used, and now the computers are being more and more available for the for the public use, rather than just being used in the organizations and companies. So computer programs were written in order for different purposes. So purpose of planning. These are the steps to write a computer program. So purpose of planning a computer program. Then these are the ways that a computer program can be written. So purpose of planning a computer program: algorithm, flowcharts, decision tables, then pseudocode. So you can see the example of flowcharts. Then decision tables are simply it simply states the situation that will be in the decision table, and what steps to be taken if that situation has been there. So that is the way the decision tables work. So as the computer programs were written, and there were different languages that evolved. First was Fortran, then COBOL, C, Python, Java, etc. So machine, so there are machine language where every architecture has a different. You can see the machine code for for 32-bit, the PPC, the 64-bit RISC, etc. Then there was assembly language, ASM86, ASM68K, etc. Then high-level programming languages were evolved, where the use of compiler, which translates the language from high-level language to the binary, then linker, which links to the library, then interpreter from translates to intermediate code, like it's used in bytecode for Java. Then object-oriented programming, where you can use the as so there are properties to the object-oriented programming, some of being inheritance, polymorphism, classes being assigned, and the class. So basically, an instance can be so uh, so it can be used as an object, and certain attributes can be assigned to them, and which was reusable uh, in other parts of the program as well. So that is what the object-oriented programming is famous for and is useful for. So other high-level languages are Go, Rust, Kotlin, SQL, which is a data management language, then JavaScript for web development. So, so as we are now writing the programs, and now humanity has been writing the programs, and more softwares are being written. So there is uh, a way of uh, maintaining the software, which is in present day is also called as DevOps, and continuous integration and delivery or deployment. So testing and debugging, and testing for the bugs, and removing the bugs. Then documentation of all the how the software was written, because the team that might have written the software might not be present in the future in the same company, but rather uh, and different team might have to work with. So the documentation of the software helps in that. So change over to new systems, uh, from older to newer systems, then system evaluation, what is the performance of it, and the maintenance of the system. So below in the figure, you can also see the DevOps cycle. Well, first is the requirement, then is the DES, design, then development, then testing, then release to the ops. Then there is a production release and the integration testing, then the staging. So these are the parts of the DevOps and that are currently being practiced by the industry. Next, we have the operating system, which is a primary use of the operating system was to convenient to use and let uh, so so convenient to use and managing the resources of the computer system. So the main function of OS is process management, memory management, file management, device management, security, command interpretation. The popular OS systems are Unix, DOS, which is a disk operating system, Windows, Windows NT, and Linux. So you can see the stack and its representation on it. Starting with process management, memory management, DM, FM, security management, OS or shell, and the applications are on top of those. Next is application software packages. So, uh, so as different softwares are being written now, as the different softwares are being written now, the the software for specific use cases were written. So word processing package for reading, writing, printing docs, a spreadsheet package for data analysis and tools, or for keeping eye on the items that are in the store and whatnot. Then the graphical package for drawing, creating, editing graphs, pictures, videos, etc. Then softwares for personal assistance or personal or individual use, which is tracking the personal finance, managing the address book, to-do list, or inventory management. So below also you can see the table where it shows the uh, it shows the various uses of the application software packages in terms of verticals. Verticals being finance software, manufacturing, or bill of materials, then space labs for scientific softwares. Then in horizontals, in the ERP, human resource management for HRM, then graphical studio software, MATLABs, application package for office software, graphical software, scientific software, then bundles of it being Word, PDF, spreadsheet for office, then graphical software, the Paint, Photoshop, After Effects. So for scientific, AutoCAD simulators and emulators, etc. So, so the application softwares are in a way more focused on some area of use. Then the data, business data processing. So one is information and one is data. So information, so data is basically a processed information, because not everything that we need in the information can be used for us. So we need to process the information in order to get it usable, and which becomes a data to us. So, uh, so the conversion of information to data happens. Then the standard methods of organizing the data, which is a file-oriented approach, which is a file management system. Then database-oriented approach, which is a database management system. So the files are all. So the working of the file management system happens in this way. The transaction files, master files having the contents of all the files that are currently being used. Then output file contains if the whole output and the and the result is convenient that for to be printed. The output file is used, the report file which contains all the reports, the backup file which is a copy of the files and all. So the file system is used is divided in accordance with the use or how it is applied. So the files are interconnected, meaning that one information in one file can be connected to the other information in another file, and the storage of files in one particular and of all the files in one particular location is called a database. So database models and database architectures are used. So for this, we have a hierarchical network database, relational database meaning similar to files, the database themselves are connected. So one information of database is connected to another information in the database. Then object-oriented database. Further, as the database are being connected and the computer is more and more becoming more powerful, and the need for getting the computer connected to different computers and to the world has started. So the basic element of computer communication system, the techniques, channels, and devices used to transmit data between distant locations, the various types of computer networks, communication protocols, which are rules and procedure for establishing and controlling the transmission of data from one computer to another, and the characteristics and advantages of distributed data processing. So you can see the various protocols that were being uh, that are being established now. So uh, for uh, for the transmission of information from one computer to another. So as the computer were becoming more and more uh, powerful and also being connected to one another for better use of it, and the internet has begun, which means to connecting the computer to the whole world. So the basic service to it when it started was to email, file transfer protocol, telnet, usenet, news, etc. So then there were internet search tools where www or World Wide Web had uses the hypertext. So that is the reason we use the hypertext transfer protocol. And the www web browsers for browsing the internet. The line browsers contains only the text can be used by the browsers, then graphical browsers, then Java enabled browsers. So the difference between all the other browsers and the Java enabled browsers were before that, and these were static browsers. So in order to see any change, you cannot see it live. The Java enabled browsers were dynamic, and any change that were happen were able to be captured by the Java enabled browsers and can be seen in real time. So there were different ways to get connected. So direct and lease line, remote dial-up, SLIP and triple P, which is a point-to-point protocol, SLIP being the serial line internet protocol. Then commercial cloud services. Then the multimedia. So multimedia is more than one, multiple medias, meaning more than one kind of media. So the commonly used media are text, graphics, animation, audio, video, and the different types. The ways these media can be stored, which is compression. Whenever they are stored in bulk, they are compressed a bit and then stored. And representations of media in different formats. So for audio we have MP3, then for video we have MP4 and other extensions. Next, we have classification of computers. So, in classification in early days of development of computers, which is size, processing speed, and cost, is not more relevant in the present day scenario. But the classification of computers, some are notebook computers, which are laptops, the personal computers, PCs, workstations, which are more office-oriented, mainframe systems, supercomputers for uh, more heavy data processing and accuracy, then client and servers, and then LAN or WAN or Internet of Networks for connecting them. So these all were used using the reference that was mentioned by C-DAC for the course, which is Foundation of Computing. And so this was the whole short summary to the whole book. As the book itself is has a lot of contents, and it should be self-studied to somewhere, because it's not possible to discuss each and every topic in an hour of time. So it was just a summary to the contents of the book. So thank you everyone for listening.
Thanks, Jamit, for the introduction to the fundamentals of computing. It was nice. There is a question I have for you. If you go back to the slide on the gates,
Yeah.
like to hear about these gates. Can you explain what this logic is? What is this OR?
Okay. So the org. So there are different logic gates, as you can see on the diagrams also. These and the input to them are being uh, and, being stated in the truth table. So we have input one and input two. So the first input, so the first row is the input is 0 0. So uh, the output to it and for the OR gate is 0. Then for AND we have 0. For NOR we have 1. So NOR is basically the reverse of OR, and NAND will be reverse of the AND. Then we have exclusive OR gate, which has a output of 0. So so basically OR operates in a way where if if one of the value from 0 onward, if happens to be 1, it will be 1, which is reverse for the AND gate, where 0, if only so only one has the value of 1, else all of the values of the combination of two inputs that are being given to them are 0.
Okay, that looks good, sounds good.
Yeah.
So these are the OR and NOR, NAND, and XOR logics,
Yes.
which are the most common ones.
Yes.
The first one is always 0 to 1, 1 to 0, that is the NOT gate.
Yeah.
Now I have similarly one more table I saw where you can go back. I want to know something. Yeah, even before this, I think. Yeah. Uh, no, not before this. Let's see. Yeah, no, the first. This is okay. First generation, second generation. Go slide by slide. I think we just want to review if you have missed anything. Number system. Yeah. So number system. When we go from 0 to 9, after 0 to 9, 9 symbols are exhausted. So we have to repeat the first symbol 1 0. Correct. So in
Yes.
decimal system, we go 0 to 9, 10, 11, 12, 13, 20. And so every 10, we change 10 to 20, 20 to 30, 40, 50, 60, 70, and so on and so forth. 100, and then we start with the number. Same way in octal, example, in binary, we always have 0 and 1, then we have to add digit, right? So when you add the digit, the LSB, MSB is on the right side, LSB is on the left side. So digit, you always start with the uh, If you go from low digits to higher digit, we call it as zero digit, first digit, or tens digit, hundreds digit, thousands digit, right?
Yeah.
In binary, you got uh, 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3, and so forth. So that's why you see 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1. Same way octal also 0 to 7, then there is no 8. So
Yeah.
it will become 1, 0. Then 1, 0, 1, 1, 1, 2 up to 1, 7. Then there is no symbol, so it will become 2, 0.
Yeah.
So on and so forth. So these are all the numbers, base 8 numbers. So there it will be base 8 to the power 0, 8 to the power 1, etc. etc. Same way here, hexadecimal you got 8 to F. So MS digit is always to the left and LS digit is to the right. It's
Yeah.
like our normal computation we do. And same way with octal and hexadecimal, and all conversions are possible. Go to the next slide here, just to review. Yeah, here you got, you see octal equivalent when you say it is 7-bit binary, because 4 plus 3 is 7. You lift the first digit, there is MS digit 8-bit. If you take, it will always be 0, right? So
Yeah.
you mentioned A as 61 here, and which is 0001, and there is a BCD zone 1 1. So basically that is 4 plus 2 6. So if you go from, this is 2 to the power
This,
0.
this is for the only the BCD code. But I mentioned about the ASCII as well.
Yeah, so the ASCII codes are 7-bit standard, and if you use 7 digits, first digit is always 0. Therefore, the code for A is 61, 62, so on and so forth. So you can have BCD as well as octal. Octal is nothing but 61, 62, 63, 64, and so on and so forth.
Hmm.
So you have alphabetic ASCII code. You can have upper digit a lower digit A, etc. Those are 128. So BCD are used for adding uh, the decimal numbers as if they were binary, right? So that's the equivalent of that. So these are some of the computer codes here. Yeah, go down, next one. Did we miss anything on this? No, this was okay. This is nothing but addition and subtraction.
Yeah.
Yeah, this is the logic, and you did the fantastic explanation on this. What is the, how do the rules apply, and
Yeah.
how does the computer scan the number and then convert it, and what is the priority left to right, and so on and so forth, all that. Yeah, so associativity law, all those are applicable. Then next slide. I think we had good, this one we had good explanation. Yeah, go ahead. This is all, yeah, processor, memory, and interconnects. Yeah, go ahead. This is okay. This was okay. Secondary storage, of course, these are permanent and non random access memory. Usually, a computer has a instruction and data.
Yeah.
And instruction and data, instruction generally are executed always on the CPU. You don't execute in memory, in the
Yeah.
have everything in the register. Once it is computed, then it goes into this one. Yeah, Amol. Hey, welcome, Amol. You have any questions? Can you at least give your uh, email ID or something so that we can interact with you? Amol, go ahead. You can put in the chat window your uh, what do you call the email, so that we maybe why don't you talk about yourself, Amol? Go ahead. Yeah, I'll unmute you. You go ahead and talk. Is Amol unmuted? Amol, go ahead. Amol, this will unmute Mike later. Okay. Okay, so we'll finish and then we'll come back. But you go ahead and put your email ID, and maybe if you have something which we can connect with you, we'll send you the WhatsApp group where we can add you, and then you can join, be part of it. So let's continue with the secondary storage. We had discussed primary and the secondary storage and versatility of the disk and all that. These are additional points you had mentioned. Go to the next slide. Yeah.
Just a second.
Yeah, go ahead, David. So input
Mm.
output devices, yeah, we had seen older methods of input outputs. Still, they are prevalent, but most of the people
Yes.
do it from their remote desktops and all that, or notebooks, or even from the mobile phones. But earlier, they used to be big keyboard and what you call mouse and all this. But these are all done through touch sensitive these days. So here the description where monitor, printer, plotter, and all this. These are all the older technologies, but nevertheless relevant in the sense of history and fundamentals of computer as it evolved. Yeah, go ahead. Input output was good. Yeah, this one was a good one for that. The hardware is at the center, and then you got the system software and operating system, which is covering the interface to the hardware. So the hardware can be driven by the machine level software or system software, which could be symbolic or it could be machine code depending on the architecture, like x86, x86 64. Could be a PPC, or it could be some RISC processor, and so on and so forth. So binary code, they may not be uh, compatible with each other because the instruction set may be translated into machine code differently. Therefore, it always depends on the architecture of the hardware over which the system software or the firmware runs, and which is then symbolically converted to high-level languages, and applications use the high-level language too. So it's a stack. So that this is a good. Let me go ahead next. Here we had talked about purpose of planning, of planning, how do what is the logic, what is the computation, how do you represent them through flowcharts, or if you are drawing pseudocode, or if you are doing decision table and various flowcharts and all this. So this was good. Yeah, go ahead next. So planning of how to do programming you must know,
Yeah.
and then obviously uh, there are formal program languages, formal, and then you have to design them, and they are based on the what you call pass, one pass, two pass. We have to go over to convert from the assembly to uh, what you call the so there are symbol tables, and that's a part of the operating system and manipulating how they does in the software. So that is part of the system software. Yeah, go ahead next. Then we had, of course, these were the computer languages we pointed. There are many, but to be very specific, these days Python is the most common one. There are other like Java has become little outdated. C continues because of the efficiency. Java, but many codes are in Java, so you wrap around. You can use language to call Java, Python can be used to call Java, and so on. Architectures and different languages, native as well as compilation, as you had mentioned already. And there are new programming languages like Go, Rust, and Kotlin, and with their own advantages and disadvantages. So Go is one of those popular, besides C for some of the Python and go together. Rust and Kotlin are obviously efficient in terms of memory and in terms of object orientation, and a lot of it is promoted by Google on their cloud. SQL is the standard query language. JavaScript has been there from the type of which were there from the days of Mosaic or the web server. Go ahead. So languages is fine. I don't see any questions on that. Go ahead. Yeah, here there was something which I had to correct, I think. So you have CI and CD. So continuous integration, continuous. Uh,
Deployment.
and here what we had is requirement you have, then you have design, development, testing. Then first release is released to ops. Ops is nothing but operations.
Yeah.
Afterwards, it goes into staging. It not goes to the production release. That I think there was some confusion there, which I want to correct. So
Okay.
go to the staging, because when you say ops, there is a staging, and so people who stage is the one where they test it, modular testing and all that. Once you do the modular testing and then you do the integration testing, finally you bring it to the production and release. Production release So it's a infinity loop where you start with requirement and midway through release ops you switch over to staging, modular testing, integration testing, and then production release. So production release are the ones which are kept on the GitHubs and checked out from the GitHub by the people who want to. Generally, you don't do any what you call modification to production releases. They are maintained. If there is any change, it should be done at the changes in the requirement or anything in the development or in design. And so the production release keeps on like 1.2, 2.2, unless there is a major change, you don't change it to 2. Like Kubernetes 1, Kubernetes 2, 1.2, 1.3, 1.4, etc., 1.5. So same way with OpenStack and same way with the system and application software also you maintain similarly. So important thing is you do design and development, then you release to the operations. Operation does the staging and testing in the not on the real production, but on the staging servers in the cloud or whatever, and then you take from there and go to the production. Production releases are actually deployed. So there is a CI/CD pipeline, which is many softwares are there like CI Jenkins, then there are some other software, and also we'll learn about we'll have to know a little better because these days the AIML also has a pipeline, so everything is pipeline based. So a lot of changes in the DevOps and CI/CD. Yeah, go next. Uh, I wanted to correct. Yeah, here also we have um, processor management. In the operating system consists of actually processor management, process which are managed, and the memory that is required to run the to store the instruction. You have to pop up and pop in, pop out of stacks, whatever variables are there, and then there is a heaps and all that. So then you have device management, which is related to what kind of device are you handling, what drivers are there, and that logical level then comes down to file management. So file management is more logical, whereas device, memory management, processor management are part of the modules of operating system. Then you have got the file management. Then you have to manage the security. So you have got that inodes and all that concepts, which is part of the OS. And then shell is the one which uh, encompasses whatever built-in codes are there, plus whatever additional system software add. So the shell is like uh, your Bourne shell, which is the bash, K shell, and there are many. But Bourne shell is the most popular one in the Linux, and Linux is the one of the most open source. There are many distros and all that. We'll see all those as we move. And of course, Windows is there. They are commercial. They are supported. A lot of people are used to Windows, but a lot of people have moved on to Linux. And obviously even the Windows is including Ubuntu version of Linux, and so you are finding that the efficiency that comes with uh, for an office user, Windows is good, but for a AIML user and all those high level, high performance computing HPC users and all that, they require what you call the uh, uh, computation which is done using scripts, and so that you can automate. So shell support, of course Windows also has its own scripting and all that, but then it is by default that those who learn Linux they do better, and those who learn Windows they have to depend on Windows, but with Linux you can move anywhere. That's the reason people have uh, switched to Linux operating system, most of them, all including embedded and all the devices all everywhere. Yeah, Windows is used only mostly for commercial application, simple application. Even in the Android is based on Linux. So is what you call the Apple OS is based on Linux. So you got all of them are based on Linux base. So that is why still the standard is Linux, and others are specific to the industry, like Office if you want. Enterprises use Office, so therefore they depend on Windows because they are used to Windows. They use Office 360, which is cloud-based implementation. So operating system has stabilized a lot, but these days they are moved to cloud operating system like OpenStack, and it could be container operating system like Kubernetes. you can call it orchestrator, you can call it as a operating system, you can say. So there are many layers these days. But overall, the layering is very more and more. So full stack includes a lot of things, but this is one of the stacks. Yeah, go further. We had covered, yeah, here we had mentioned that uh, the verticals, when we talk about horizontals, we talk about application package. So when we talk about application packages, Office example, Office suite. So it's a bundle, and that bundle contains what? Word, maybe spreadsheet, slides, deck, and all that. Yeah.
Yes.
So what happened? Did he drop out? Uh,
Uh,
that's Yeah. So go ahead and keep going. So you got all this one you have done very good. So standard organization, yeah, file management, yeah, go ahead further. Yeah, here the database management we had hierarchical, network, relational. Most popular is relational, and uh,
yes.
other one is what is it? NoSQL.
Oh, yes. Post.
NoSQL
Yeah.
raw basically. So that is the one. Object databases are also there, many. So yeah, that databases you have explained well. Go ahead. And then we had data communications. Yeah, of course, we had talked about protocol. Yeah, here we had to go to the next slide. I think that I had some more. You skipped this a very, very faster way. So what we had is wireless application layers, WAP layers, so application layer, session layer, So this is a OSI layer stack. The wireless layer is a physical layer. The physical layer can be wired or wireless. Transport layer is all related to datagram, protocol, and all. And security layer, of course, you have transport layer security, TLS, 1.SSL 1.0, 2.0, TLS 1.0. Then you have transaction layer, which is obviously the transaction layer deals with the what integrity. So asset properties have to be there, and that is uh, atomicity, concurrency, integrity, and durability. Those asset properties have to be there in the transaction layer, and so that is one thing. Session layer is obviously for the anybody can use, like HTML. We have HTTP 4 and 5. HTML5 also is there. So those are hypertext languages that are used. And application layers, obviously we have markups which can be used depending on the browser. And there are many scripts, and these days, what is called uh, Wasm has come, so there are many improvements in uh, the layers of web, W3C based. And so that is something which I think you skipped a bit early, so I wanted to stress on that. Go ahead.
Okay.
Yeah, then I think that is all we have. These are all standard.
Yeah.
So this file transfer protocol, FTP and TFTP, and there are many a protocol, Gopher, and these are old ones. Now these days everything is readily available through download and upload. So people, most of them don't even know what is. They just do download upload from the servers, and they have no clue. Neither they need. If they don't need, they don't need to know. But as a computers AI designer and what do you call the PG diploma in AI, you will need to do that. Yeah, you will need to also look at cloud services which are not there in the earlier one. We need to do cloud services, all either public or private or whatever, hybrid, whatever. Yeah, go ahead next. So I think that's all I had. You have,
Okay.
yeah, well, go ahead next one. So essentially, we have brought in yeah, go ahead. Classification of computers was fine, no problem. So this is the reference. So we
Yeah.
might references. That is what I wanted to do. So
Okay.
what we have is no whatever input from over. Okay. So I think I'll stop recording
Yeah.
here.